all the sources on that. Yeah. You can add the sort of optional directories, everything that you want. And the compiler should be able to resolve anything that it needs from that source path, compile anything that it needs, and doesn't require for anything to be actually compiled. So if you put everything to that compiler, it should work. In theory, of course. We checked and it works a lot of cases. Yeah. And currently, we also, even if you import, if you have BSP information, so you actually have information about where the sources are located, we will give the presentation compiler all the sources. So if you have anything broken, nothing is compiling, you should still get everything to be up to date, every change, everything working correctly. And there's two main improvements that make it possible. So everything in the compiler is lazy. There was an additional change that made it even more lazy. So every file that you put to that source path is pre-parsed, and we check what package is responsible for each file. So if the compiler then queries, because the compiler usually lazily just queries the packages that it needs, so we just give it the files that we know the package is contained in, and the compiler only needs to compile those specific files. So this is an example. If we have 3 different packages, if we work on main.scala, which only use the util package, this file, which is not related in any means to the main.scala, is completely ignored. So in a lot of the cases, it will be a lot less code actually compiled, and even looked at. You don't need to load any sources that the package doesn't match. We can also do another thing. There's a second thing that makes it fast, is that if you have explicit types for every method inside every class, we don't actually have to compile the bodies. So we can just skip those bodies. So I suggest that you use explicit result types rule from ScalaFix, which will do that for you. You don't have to specify those types. And that helps a lot because if, for example, we are editing the main.scala and we are referencing some other package, some other file, we can actually skip everything inside of that file. So any file that is not being actively worked on, that you're not looking at, will have almost no compilation done. If we have types, that's why we can put every source file into the presentation compiler, and it should work perfectly fine. So bodies are ignored. Of course, source path allows you to put every source that you own, the sources in your project. But dependencies is another thing, because if you don't have BSP, then you don't have information about what dependencies, libraries you might need for the presentation compiler or just the compiler to actually work. For that, we have this additional, and this is why I think Olaf mentioned MBT being Metal's build tool, but it's really about one file that has information about all your dependencies. And we also put all those dependencies, if you create that file, because it's currently not created automatically. If you put all those jars, the presentation compiler will manage to load what it needs, and it will work actually correctly. It's a very simple format. It's just a list, really. We have extractors for Bazel, Maven, and Gradle. We haven't added one for SBT because it mostly works with Loop correctly, but I actually created an extract from SBT if you need that. And the idea is similar to log files. You can create those files for your repository beforehand. So then if the user, another developer, opens up the repository, we have those fast indexes. We have the log files which tell us which dependencies we want, and the presentation compiler should be able to pick that all up and just offer you full features of the IDE. We might even not need an actual build server, not need to connect to anything a lot of the time. Obviously, if you have BSP, if you're connected to an actual server like SBT or Blue, then you get those dependencies from those servers. But then if there's nothing there, we'll fall back to mbt.json. There's also a possibility, but we have turned that off because Olaf says it's a hack. I don't know if it's that much of a hack, but we can scan any existing build-to configuration, like things inside .bloop, to actually get the dependencies from there. But it's turned off by default. Maybe if mbt.json is not enough, we'll turn that on in the future. It does also help MBT of the source path option also helps if you have the project structure and everything imported, because the source path option is always on. So you get always up-to-date information, which is compared to how Metals works currently, it's a much better and much smoother experience for everyone. There's also some other options. I just mentioned that, but you can try, if you're trying to get something going for a large monorepo, you might want to experiment with those. But if you don't need to set something up for other developers, you're probably fine not looking at those configuration options. They're not yet documented, so I will have to work on those, make sure they're all documented and make sense. Remove anything that didn't make the cut when they backported things to the main fork of Metal. I also mentioned that there's better Java support because we want to, and especially I think Databricks, they have a large Java, a lot of Java source files as well. So they wanted to improve the Java support. And we needed to, or they needed to step up the Java support. And for that, we implemented, I implemented some of those features. There were some additional features also implemented within Databricks, but we made sure that most of the features that LSP needs, like hovers, completions, that all of that is available to the users. We didn't work too much on any large refactoring code action stuff like that, because for now, it seems like in the LLM era, those large refactorings are a bit too stable, I would say. So the LLMs might do things much more faster, and there might be some ways to connect some existing tools to LLMs to make refactorings much easier for some custom stuff. All those features currently are supported. There's probably more which I forgot, but completions, hover, signature help, and diagnostics are done by the presentation compiler. So that it is basically our presentation compiler built on top of Java C compiler, and it works pretty well. It uses just the normal Java C, so all the results are correct. There's also semantic highlighting, which is a way to, it's a bit better than syntax highlighting in regards to types of names you have. So we can say that you can have classes, objects, everything colored differently. If you use semantic highlighting, variables can be colored differently. All that stuff is based on the semantic information about the code. That uses Java Semantic DB, which is, I will not delve into that, but Semantic DB is another protobuf document that can be produced from a file to get as much information about that file as possible. We used Java CAC, so just the parse trees for selection range, which is the feature to select more and more in scope. Document symbol, which is searching for things within a document. Go to definition uses both semantic DB in Java and MBT, so it just gets information about what symbol there is, and then goes back to MBT, which has that information where that's located. Find references similar to Scala, it uses MBT and Bloomfield. But what wasn't efficient was Java support in large code bases. To make that happen, they introduced Go Turbine, which is this way of compiling a lot of files, a lot of Java files, and creating class file in memory stubs. So those class files are then given to the normal JavaC compiler, which doesn't see it as anything weird. And those class files are also very similar. They're only outlines, so it doesn't compile anything inside. It's very fast. And it works with the normal JavaC compiler. It doesn't work though with Project Lombok or any annotation processors. So if you need that, there's an option to turn off Turbine. Currently, if you will want to use it, and the presentation compiler will just not show any of the methods added by Lombok or anything. But, not sure how many people use Lombok, if it's very popular. I think it's popular, but I have no idea. Okay, so how does it work? So we have a lot of Java files, for example, in a project. We put all of those files into Go Turbine. It creates those class file stubs in memory, and then it gives it to the presentation compiler we wrote. And when we are editing, for example, file.java, then that file is using the JavaC outline compiler, which is another thing that was added. Although if you're in file.java, we will anyway have to compile the full file. But then if you have something that was edited, just you switch between files and you edit something else, then we will also use the source path option for the JavaC compiler, which as well has the source path option. And that source path option will also use the outline compiler and will skip all the bodies of any methods, but should also be fast. And then after a minute, everything gets recompiled with Turbine. So you're back with the class file stub. So it's mostly using Turbine, but anything recently edited or anything that is broken will be using the source path option and will be loaded to the compiler. No. Why not just use source path? While the Scala source path is very efficient, the JavaC one is not really, and it just goes cascading to compile a lot of different files. So it was done in order to make that viable approach. And if you have, for example, nothing imported, you just have a lot of Java files, it will still work, should work perfectly fine. I should because there's so much different code bases that there's always one code base that will break. Yeah, and source path will anyway will be used for anything recently edited. And if you see any problems with Turbine, maybe it's not fast enough, you can switch it off, or you can turn the intervals. You can make it go every 10 minutes, every 50 minutes, and then the source path option would be used in between those 10 or 50 minutes. And overall, the Java support is very similar to the Scala support. So we have outline, source path, making sure that we can just put everything out there to the compiler, and it should return the correct results to us. Okay, so those three things, so Java support, the Scala outline presentation compiler, and MBT are the main things. But when will that get released? So the main things are making sure that every change that were introduced within methods at the point of 1.5.2, which is when the Databricks fork was created, that we port all the features and fixes that were there. Scala 3 is not yet working fully because the source file option is there, everything is there, I just need to integrate it, and I'm working on that currently because Databricks has 2.13, so they didn't care much about Scala 3 in that regard. So that's my job here to make it work. We need to make sure that all the build, it was mostly tested with Bazel and Loop. So we need to make sure it works with MIL, BSP and stuff like that. Make sure there's nothing weird about that. and I want to document some stuff, especially the options that you can use that might be useful to you. And there was a lot done to improve the basis support on the Databricks fork, but it was based on a Bazel BSP that is internal to Databricks. We are actually working because previously we were using the Bazel BSP from JetBrains that we've now forked and tried to maintain, but it's very hard to maintain that. The code is not perfect, I would say. So we are working on inlining our own BSP server because we can do that with LLMs and it actually works pretty well. And we will have our own BSP, which we can fix quite quickly. And it's much easier we wouldn't have those information that BSP provides, need to go through some JSON RPCs, which goes through sockets. We'll have that inside Metal. So one less steps, and Bazel is it's used in pretty large code bases. So you don't want to put all that information through sockets. And if you want to try it out, we would be happy to help you out, try to improve your workflow. If there are contracts needed, there might be, you can contact us, but mostly if you have any questions, I would be happy to help out, work on anything that you can share, help with anything you can share. But we need to test it, make sure it's working, and it's actually improving people's development workflow, their life. So that's the summary. As I said, those three main things, the Java support, MBT index, and fast IDE features are the selling points and the changes in Method 2. And if you want to use it, you can build it from source if you're keen to do so, but you can also change the Metal server version to 2.0.0 M8. The M8 version was released today, because I realized something I wanted to show wasn't working, but it's not working. But that's my main focus currently, to make sure that we go towards the actual 2.0.0 and we have all the features that were done previously and everything's working. And people don't have to deal with indexing times and build times and everything. Everybody's happy. That's the idea. All right, thank you. If you have any questions, go ahead. I don't have too much time, but I can also show a demo of some stuff.
You just showed something about setting the metals version.
Yeah.
You just showed something setting the metals version. But where do I actually set that? And this is
that depends. So because Metals works with so many editors, each editor has a different way of specifying that. And for VS Code, cursor, and everything based on VS Code, that is in settings inside. If you search for normal settings, Metal server, then you'll find it. For a lot of other editors, you actually have to set up the Metals binary in the path. Then you have to actually bootstrap that specific version or install that specific version using Coursier. Every editor has a different way of doing that. That's why I should have mentioned more about that, but it was already a long talk.
Right. I think this is part of my larger question, which is my biggest problem with Metals is I can't fix it when it goes wrong. I just don't understand how it all works. And all the documentation talks about VS Code, which I don't use. So is there anything that we can do to make that situation easier?
So to make it easier for you to figure out what's wrong when it's wrong. Okay. So ideally with Metals 2, even if you don't have that set up, it should work. And we should be able to set up things like MBT JSON so that you don't have to work with that. And but there might always be things that go wrong, unfortunately. So we are going the other direction. So we're making it that even if it goes wrong, it should still work kind of, or more or less, for most of the stuff. But yeah, to make it work, like I've seen so many weird issues people had because their setup was different, because we didn't think about something that it's very complex to make sure. We do try to add, like every time somebody reports an issue, I try to make sure that next time this happens for someone, they will know how to fix that. But I feel like there's an infinite number of possibilities of things that can go wrong. So that's not an answer that helps a lot, but please report issues. I'll try to fix them.
I have more to say on that afterwards.
So I have a question with context. I haven't used either version of Metals, but when you're talking about providing more information immediately at startup, what sort of tolerance are you giving for incorrect answers? For example, if you have class shadowing, it means that you're getting some false matches when you're kind of optimizing.
So there's no logic that will make sure that will not happen. But we're hoping that even if there's a false positive, it's pretty clear if it's a false positive. But it's better for us to make it work even in those cases that we show maybe some wrong things, but it still works for the most cases, than not show anything at all. That's the idea. But if you connect to BSP and you have the normal class path, then everything should work reasonably well. And also, as I said, the improvements we did on Metals 2 should improve as well the normal workflow we'll have with BSP Connect.
Great, thanks.
Any more questions? I think we do have time for the demo.
Okay, so let me find where it was. Okay, I think this is one. This is Metals. Yeah, so I have a Metals repository which has nothing imported. I haven't imported anything at all. Let's see if things actually work. Okay. Oh yeah, sorry. Okay, you can see that actually there's nothing imported. There's no .blue, which is the BSP server, but then you actually have things working. I haven't created the MBT JSON file, so you can see that there's some errors about missing packages, and that's coming from the presentation compiler. So I haven't mentioned it, but the presentation compiler will also show you errors now. But you can see that overall, even if you don't manage to import BSP, you get some kind of a support. Not perfect, because anything outside from different libraries will not work. For example, if you try to complete find, that's actually working because we have find a string. But yeah, you can already work on this with stuff. As anything that is in the current workspace will work. But I actually, so as I said, the MBT JSON is very simple format. So I actually created this vibe coded, really, this script that just extracts things from SBT. And I think I can run it with Scala CLI. And that should, so I had a crazy idea that I do just SBT show library dependencies, parse that, and just download everything. There's some heuristics about what I download. Just in case I actually have, you can see old MBT, that's what I generated previously, but let's see if it still works. If I tidy it up, I should be able to just make maybe make it a possibility for people to actually use that in metals. I haven't figured out the user experience yet of how that would be. Why would you choose MBT? Because it's more of a, it might not work perfectly if there's some conflict between symbols. So maybe you don't want to use MBT all the time, or maybe you want to use it in some code bases. As you can see, there's a lot of jars being downloaded, or just here, they're not even downloaded, but just check. If it takes much longer, I'll just copy over the old stuff. But yeah, it's very simple to create your own MBT JSON. You can do that even manually if you want. Or you can create your mini build tool that just creates that, and it should work. I just created this script for today. It's nothing that I want to ship. But yeah, we have a lot of, if you look at our dependencies normally, here, that's metals that is actually imported. So we can see how many we have. There's like 488 libraries. A lot of that is from SBT, but all that is being actually checked here. So we have Scala. Oh, okay, it finished. So you can see it managed to download 385 dependencies. Okay, and now let's see if it actually helped with anything. Okay, maybe not sure if it indexes correctly on it. I don't think it indexes correctly when we have to add that. But yeah. Yeah, now it works. So I downloaded everything. You even have sources. You get parameters are from LSP. Get arguments, everything, and everything works. There's no actual build tool underneath aside from MBT JSON, and it has a lot of jars. Because the Scala compiler is very smart about what it loads. So if you want, you can just we could even make it not be here in .metals. We could make it configurable so people can configure it for themselves, and if they have simple enough code or not, no conflicting dependencies, we could have MBT JSON as like a first line of defense. So then the import could happen, and we could make sure that we reload the class path and everything uses then the normal class path. But at the start, we could just all use whatever was generated before. Of course, this would need to be smarter than just jars on the local class path to probably make that happen. There's a lot of things we can improve here. A lot of people have stable identifiers for where the jar are on monorepos, so that's also a possibility. Or just running the extract might be faster than running the import. But yeah, it works with just that stuff set up, and haven't found any large issue. The only issue I managed to find is when I didn't actually add a dependency, and it was then it was red, but I think I fixed the script enough so that it loads everything. Works without anything added aside from MBT JSON and source path. So yeah. Work, the demo worked. Yes. Yeah. Okay. Any questions to that?
I think we can take questions over pizza.
Yeah, if anyone has questions, you can approach me. Otherwise, there's good stuff. Yeah, thank you.